Hello and welcome to this video where we'll come into OOP theoretical, and here I will dive in a little bit deeper into the different concepts that we've learned. So we have used, for example, dunder init for creating in the classes to initiate the different variables. However, we'll go a little bit deeper into the instantiation process of creating a class. What happens when you create the class? And then we'll go a little bit more into attributes. We'll go into namespaces. I think we haven't gone through namespaces before, so that is important to go through. And then we'll check a little bit of class scope. We'll go into property. Not only will we create properties as we've done before, but we'll show how to create our own properties. We'll show why you should use properties in contrast to getters and setters that you usually do in many other languages. So here I am in Visual Studio Code, and as you see, this is an empty folder, and you should definitely work with Git and GitHub repository. So I will create a virtual environment and then activate it, bin activate, pip install. I only need IPy-kernel for Jupyter Notebooks. Then I'll close this down and I will open a new file here. OOP theoretical. Let's see if I can spell it. I pin B like this. I'll choose my Python environment, my virtual environment. OOP theoretical. Okay. So let's start with class instantiation. So when you instantiate a class, what will happen is that you will have dunder new. This is a dunder method that will be run, and then we will have dunder init that will be run. So when we create a new instance of the class, a dunder new method will run, and then the instance is initialized. That is the dunder init is run. So when we run the dunder init, we usually put in some initial state for our object, right? Oh, sorry. Let's see if I can. No, I don't want. I want to have backslash here. Okay. So let's create a class now. Class student. Just pass and see what happens. So S1 equals to student. So we call the student class. So if we take S1, we have that this is a class that lives at, this is an instance of the student that lives in this memory address, right? So we can do type of S1, and we can see that it's a student. So it lives in dunder main, and it's a student. And we can, when we do is instance of S1, let's say S1 comma student, we see that it's true. We can create another student, S2 equals to student as well. And we can do is instance of S2 of student, and we can see that is true as well. However, S1 is not equal to S2. This is false. So S1, if we check the ID of S1 and we check the hex of that, we can see that this is the hex of S1, and we can check the hex of S2, and we can see that they are different. So they're not the same. It's different students. They live in different memory addresses, but they are both an instance of the class. So we've instantiated two different instances from the student class. So, for example, we can create this student class again. But now we have dunder init. We just print. And then if I do student now, and I call it, so it's a callable. So a class is itself an object of type. And the class, each class in Python is a callable, which we call using this syntax. So we can actually run this one, and you can see that dunder init is run. So when we create this one, and when we instantiate from this class, the dunder init is run. If we take dunder new as well, and we say print dunder new is run, and you can see which order it's run. So here, dunder new is run. So as you can see, only dunder new is run, and the dunder init is not run. And the reason for this is that dunder new method, it does not return an instance now, while and the dunder init, it requires an instance. But the default implementation in Python classes, it will return an instance. So that's why the dunder init will be called. But seldomly you will be using dunder new. So I will just remove this one, just to show you that the new has precedence over dunder init. So now dunder init is run. Okay, so let's move on to attributes. Attributes of a class are state that holds data and methods for functionality or behavior. So attributes, they can belong to the class itself or the instance of instance attributes. And the state is basically the value of the variables. Actually, I can copy in my notes here so that you can see it as well. So attributes can be created inside methods. Attributes can be created on the fly using the dot notation. Okay, so let's create a few attributes. So we have S1 equals to student. So S1, yeah, you can see that these are run. We can do S1.name. And you can see we have an attribute error because the name does not exist, right? The object has no attribute name. So to see its attributes, we can have dot underscore, and this is an empty, as you can see, so we don't have any attributes here. However, we can create an attribute on the fly. So s1.name equals to Ada. And then we can do s1 dot dunder, and you can see that the name is Ada. So it created this on the fly. That is, it created it in runtime. And you have seen in previous lectures where we have created attributes inside of classes already. So let's move on to methods. Methods are the behavior of a class. It constitutes our methods. And methods itself are also attributes of the class, right? So let's create a class student. And the student, which let's do dunder init here, and give it a name. We have self.name equals the name. The study self, so this is a method. Return f-string self.name is studying. Let's see, is studying. So S1, let's start with this. So the study is an attribute of the class, which is a plain function, and as it's not bound to any object. if you run it like this. Let's see, student.study. So this works. So it's a function. It lives inside of the student object. So the student class, you see it's the function name. So this is an attribute of the class. So what you can do is basically like this. You can put in here S1, for example, and you can see Ada is studying. So S1 is the student instance, right? Which we have created before, which we have instantiated before. And we can pass this into this function, because this function, it takes self as a parameter. And self, what type is that? It's a type of an instance. So we send in an instance here. And the instance itself, it has the name, right? That's why we get Ada is studying. As simple as that. However, now we used it by calling the function. So it's not a method, right? It's a method when it's bound to the self. So it's bound to its instance. So, for example, however, if you do like this student.study, and we call it, before we didn't call it, but now we call it without an argument passed to it. And you can see it says missing one required positional argument self. So what happens when we do, for example, like this? Student of Ada. So now we have instantiated an instance of this class, of this type. So it's a student instance. And an instance, when we call .study, you can see what happens. Ada is studying. And this is because when you do call .study, then this instance itself is passed in as a parameter or as an argument. This is what happens. So by default, when you have created an instance, the instance itself is passed in as an argument when you call the methods. That's why you usually don't, or you can't supply a self. You don't supply any arguments here, right? Because always the first argument that is passed in is the instance itself. That's why we call it self here, right? So this is how it works. So we could, for example, if we copy this one and run it like this, you can see it's a bound method. It's a bound method to student.study of this object here. I hope this was understandable. It's a little bit more deeper than what we have gone through. Before it's more like we use it and accept it, but now we try to dig deep in what is actually happening behind the scenes. And it's quite useful to learn this, because then you understand more of how Python works and what you can do with it. So namespaces is the next part we'll go into. So I will just copy these notes as well. So class attributes, they live in the class namespace. A namespace is basically a dictionary of symbolic names, so keys, references to objects, that is values. And Python, it will first search the local scope, which is the innermost scope of a function or a method. And then it will go on to the enclosing scope, which the function or method resides, like where is the function living in, and it will look into that scope. And in a class, this scope is the class namespace, and then the interpreter goes to look in the global scope and finally the built-in scope. Okay, if this is quite gibberish for you, hard to understand, let's see with an example. Class, rabbit. So here we have class attributes. They exist in class namespace, not in instance namespace. So eyes equals 2, nose equals 1, has tail equals true. So these are class attributes. And then let's copy, and let's copy a few. So we make dunder init, and we have binky. I'll just translate this to English. Happy and jumps around. Okay. So we have dunder init, and as we talked before, is that it's a special method. It will affect the object when an instance is created. The init will run to initialize that instance. And these are the behaviors of the class. So here we have behaviors. So technically they are functions of the class, but they become methods first when the instance object is instantiated. And then these will be bound to the instance. So now we have, let's see, we create a rabbit Bella, and we create the rabbit, say rabbit 1, rabbit 2 is a rabbit of, let's call it Scoot. So we can check out rabbit1 dot dunderdick, and you can see its name is Bella. Rabbit2 dot dunderdick, its name is Scoot. So we see that in rabbit's instances only has name in its namespace. This is the local namespace, right? So here we have a local namespace. So we don't have these class attributes here. These are in the class namespace. But when you're looking in the instance itself, it's here. However, if you look into the rabbit's namespace, so rabbit is the class, right? And we look into its namespace, you can see here, it's a mapping proxy, but you don't need to know what this is for now. So you can see here, it's the module, it's done the main, eyes, 2, nose, 1, has tail, true, and these are the different functions it has, done the init, binky, it has this dict method as well, and it has some other things. So you can see that it differs, like this namespace of the rabbit compared to the namespace of each rabbit instances. So if we look into, for example, as you can see here, if we take the rabbit and we take dot name, it doesn't have it, right? So type object rabbit has no attribute name because these attributes, they are bound to the instances. So in the class scope, we don't have this name attribute, while in each of the instances scope, we do have this name attribute. So for example, here, rabbit1 dot name, you can see we have Bella. Rabbit2 dot name, it's Bella as Scoot. So these are the namespace of, so they live in the namespace of each instance, right? While these attributes don't exist in the class namespace. So class namespace doesn't have a name attribute. So it's not in their scope. So this is the class scope, while here we're inside of the rabbits, each instance's scope. However, we can do this. So we could do rabbit.eyes, right? And it's 2. So this is no problem because eyes are in the namespace of rabbit, so it's in that scope. However, rabbit1.eyes, it also has 2. Rabbit2 is also 2. This is because, so eyes don't exist in each of the instances, right? So if we take rabbit.dunderdict, you can see we have name Bella only. However, if it doesn't find it, so it doesn't find it inside of its own scope, it goes out to check the enclosing namespace, right? So looking for, does rabbit task have this attribute or not? And it does have it. So then that's why we can do rabbit1.eyes like this. And let's see. For example, we could do like this. Rabbit1.has tail. As this will work because it takes the class instance, class attribute, right? But if we change this to false, what will happen? Rabbit1.dunderdict. And now you can see it has tail false, right? However, rabbit2.dunderdict, what will happen? You can see it only has name and scut still. So if we take rabbit2.has tail, it's true, right? Because it takes the class attribute, because that's the enclosing namespace. However, rabbit1.has tail will choose the one that is in the local scope. So that has precedence over the one in the enclosing scope. And still, if we look into rabbit.dunderdict, we can see that nothing has changed. Has tail is still true. Okay, so let's move on to properties. Copy and notes as well. Properties. The attributes that are directly accessed from outside of the class is called bare attributes. So it's when you can access it directly from outside, it's called bare attributes. Directly accessing some bare attributes are discouraged in times as you want to have more control of the attribute. For example, to compute a value and or to have error handling. This can be done through properties, where the bare attribute is private or pseudo-private, of course, private by convention in Python. And the attribute values itself is provided through the property interface. Many other languages uses getters and setters to provide this functionality. But in Python, we have a property function which adds functionality to an existing attribute, or a property decorator, to be more precise. So let's create an example here. Class square. So in other languages, usually you do like this: def dunder init, comma side, self._side equals to side. So this is private, right? So we make the attribute private by convention. So def get side self, and we return self._side. So this is what we do in other languages. And then I'll just copy the setter part without print, because it's a lot of validation code that I don't want to type out now. So basically we have a set side, and if not is instance value of int or float, or value is smaller than 0, we raise this value error. And then we set this value when it has gone through the validation code. So what we can do is square of 10, for example, square equals square of 10, square. And then we get this square instance, right? And we can do square dot. If we do square dot under dict, as you can see, we have this underscore side. However, as we shouldn't touch this one, as it's a private one. So we should touch it through our interface, which is .get side. And we get 10. And if we want to change it, we can do square.set side. Say if we take -5, we'll get this error, this validation. So if we take 0, it's okay. Apparently, I may have changed it, but 1 is okay. So then if we take square.get side, and we get 1 here. And if we check square dot done the dict, and we can see that it has changed to 1, the backing variable it's called. So the underscore, the private variable, which is the one that is set, it's the backing variable. Okay. So let's continue a little bit now. We copied the same code as before. Copy this code. And we'll make it into a property. So in order to make this into a property, this get side and set side, we'll do like this. Side equals to property of fget equals to get side, comma, fset equals to set side. So now it has become a property that is called side. So if we do square equals square of 10, and we can do like this square dot side, and you can see it becomes 10. So square dot done the dict, let's see what it looks like. It's still the backing variable is still underscore, right? So, however, we can do like this. So if I give a code here and I do square dot side equals to 25. And then I can do square dot side, and we see we get 25. And if I run this one, we get 25 here. And also we could do square dot side equals to -5, and then we will get this value error because it has gone through this one. Try accept value error as error, print error. Okay. So why do we do this? When we do it as a property, it becomes much cleaner code. Remember what we need to do before. We needed to do square.get side, square.set side. However, in Python, it feels more natural that you write square.side equals 25 and you use the get method, right? Or the get. And when you're assigning, you use the setter. So this is much cleaner code. And this is how you create a property from scratch. However, if you want to make it even cleaner when you're creating, let me just copy this part here. The property with decorator syntax. So you use the decorator syntax. And the decorator syntax basically here, instead of get side, we do just the side. And we do add property. And we have side here, but we do add side.setter. And everything else stays the same. So now you have properties, and you can do a computed property also if you want. So property, def area, self, return self.side square. So this is a computed property that when you call area, it will compute the area for you. So what you can do now is square of 10. And you have square dot side is 10. Square dot area is 100, right? We could do square dot side equals 20. Square area is 400. And also there it has validation. So it becomes much cleaner because when you work with the bare attributes, you use this syntax. So what is recommended and common is that usually you start with bare attributes, and whenever you need, you will move on to properties, and the interface stays the same. So you don't need to change all your code to suddenly get area, set side, similar methods. Instead, you use properties in this way. With the decorator, what it does is that it gives extra functionality to this function. The basic functionality it gives is, as you can see here, that you use the property function and you implement the fget and fset. So in this video, we have gone through different topics for OOP, more theoretical, dived a little bit deeper and tried to understand more of the underlying parts of object-oriented programming. And even if it's a little bit deeper, it's still scratching the surface. There's a lot more in Python OOP that I won't cover in this video. Maybe in future video, I'm not sure. But I hope that you've learned a lot and you can bring these skills with you when you're working with other packages, libraries, when you're creating your own classes, when you're reading other people's code. Make sure to commit and push your code. And thank you for watching this video. See you in the next one. Bye.